Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, the sine, cosine, and tangent ratios with variables for side lengths. So most people, when they think there's going to be variables, they think it's going to be trickier, but actually in this instance it actually makes it simpler because there's no way to reduce anything. So we're going to do the same thing, we just won't have to worry about that reduction in the last step. So we have side lengths A, B, and C, and we're going to try and find cosine, tangent, and sine for this. So we'll go ahead and do them in that order. The order doesn't really matter all that much. Now, something important to note here that a lot of times we kind of glance over visually is it's cosine of x, tangent of x, and sine of x. That x is very, very important because it tells us what angle we're in reference to, which will change all of these. So if we were had another angle up here, maybe a y, cosine of x and cosine of y are very different. So we kind of default to seeing x. So sometimes we don't really pay attention to the fact that it's there. But it is important. Well, it's almost always important, otherwise it wouldn't be there. But it's very important here because it'll change your entire approach to this one, since it'll change adjacent and opposite and all that, the reference sides around. So cosine is adjacent over hypotenuse. So adjacent meaning the leg that's touching, or well, it just means next to or touching. So which leg, so not the hypotenuse, which is B, but which leg is adjacent to the angle X? And that would be C, since it's actually part of the side that makes up that angle. So in this case, cosine of x is adjacent over hypotenuse, so it's C over B, and we're done there. Tangent is opposite over adjacent, so we just said C was adjacent, so the leg opposite would have to be A. So opposite over adjacent would be A over C. And sine of x, so we're still using that x there for all of these, which is nice. But sine is going to be the opposite over the hypotenuse. So in this case, A over B. Okay, and like I said, there's no reduction, so we're done.